Hello and welcome to Math 253, Calculus 3 here at Cañada College. My name is Lapuz and I'm the instructor for this course. In this video, we're going to take an overview of Chapter 3. In this chapter, we're going to get introduced to vector-valued functions. Starting with the first section, 3.1, we're going to define these vector-valued functions and see them as if they were just simply those parametric equations that we saw in Chapter 1. Now the only difference is that we're going to look at these things as vectors and we're going to be able to apply them to three-dimensional figures. We're going to call them space curves. And speaking of curves, we're going to graph these things. We're going to graph them very similarly to how we graph the parametric equations. And then we're going to take a look at these vector-valued functions and begin applying calculus starting with limits. So these limits that we're going to take are simply limits of the same old functions that we've been looking at back in pre-calculus and calculus 1, except we're going to treat them as little components of these vectors. So the calculus is not really going to be that different. Speaking of calculus, in the second section, we're going to start diving deeper into derivatives and integrals. We're going to take derivatives of these vector-valued functions and we'll do them component-wise. It turns out that the derivative of a vector-valued function is exactly the tangent vector. So we're going to apply some geometry to these things and take a look at these tangent vectors as vectors that are going to be right along the curve, tangent to the curve. And then we're going to play a little bit around with these tangent vectors and look at them deeply in the next section. Finally, we're going to take integrals of these things. Definite integrals and indefinite integrals would apply to vector-valued functions if we do them component by component. In the next section, we're going to dive into some arc length and curvature. We've seen arc length before with parametric equations, and it's not going to be a surprise that some of the formulas that we're going to see here are going to be similar to those that we saw back in Chapter 1. But now we're going to look at them in 3 dimensions, and we're also going to apply the idea of arc lengths to see if they can relate to curvature. We've seen some sort of curvature back in Calculus 1 when we took a look at the second derivatives and examined concavities. Except back then we only looked at it whether it's concave up or concave down. Now our second derivative will play a deeper part into studying these curves by looking at how much a curve actually bends. And that's going to be our curvature. Finally, back with the tangent vectors, we're going to take a look at these unit tangent vectors and create 2 more vectors to form what's called a Frenet frame. These vectors are going to be made up of a tangent vector, a unit tangent vector. That's going to be a normal vector, that's 2 vectors, and then a third vector called the unit binormal vector. And with these 3 vectors, you're going to create this frame that would run along a particular curve. So these are called Frenet frames, and sometimes they're called the TNB frame. T for tangent, N for normal, and B for binormal. Finally, in this chapter, we're going to apply these ideas of calculus on these vector-valued functions to study motions in space. So in motions in space, we're going to relate the idea of a position vector with a velocity and acceleration vector. And then we're going to dig deeper into the acceleration and see if you can write that as a component of 2 other vectors that are going to be perpendicular. And then we're going to study the whole idea of projectile, about sending things through the air and seeing when they land, and basically doing some of that stuff that we did in Calculus 1, except now we're going to do it in the context of vectors. And with our idea of studying 3 dimensions, we can also do things in 3 dimensions to see how projectiles react with gravity. There's a fourth section here called Kepler's Law, where they start studying these laws from the astronomer Kepler. We're going to take a look at that and relate it to some of the things that we've studied, such as polar coordinates and conic sections. And we'll see that a lot of these planets revolve around an ellipse, and we'll dig a little bit deeper into studying some ellipses. Okay, that is the overview of chapter 3, and in the next section we'll start getting deeper into each of these sections to study them. All right, good luck.